What's going on, guys? Mr. Jones coming at you once again. We're going to go ahead and start on Module 3. Welcome back to school from Thanksgiving break. So Module 3 is a little bit different. We're going to learn some skills, but we're only going to have about 3 lessons, then we're going to start reviewing for the final. So this will be the last couple concepts on the final. So the first thing I want to review really quick is function notation. I don't remember if we reviewed this in this class or if I did it in my IM1 class, but basically where stuff is written like this or like this instead of y. Okay, so this replaces y. So basically, look at problem number 6 on the left-hand side of my screen. It's showing you a graph for 6, 7, 8, 9, and 10. So if it tells you f of 2, first of all, this graph is the f of x graph. If I tell you, let's actually just do a different problem. Let's just go ahead and say I did f of 5. F of 5 means x equals 5, so y equals blank. That's what it means. It means plug in, if x is 5, what does y equal? Okay. So basically, go over to your graph whenever x is 5, which is right here, and then you're going to go up to your graph, and it's just under 6. So we'll say the answer is like, I don't know, 5.8 or something, okay? So the answer to f of 5 is 5.8, approximately, okay? If I told you f of x equals... Let's pick a nice number. Let's actually say f of x equals 1. This is the same thing as saying y equals 1. So therefore, what does x equal? Okay. So one of them, this one gave you x for free, solve for y. This one gives you y for free, solve for x. You're just going to go to the y value on your graph of 1. And then since we're already touching our graph, we know that the answer is 0. Okay. So go ahead and just solve all 6 through 9 is just like that. Number 10, what do you notice about the way the inputs and outputs for this function relate? Create a table. So create a table and then explain problem number 10. All right, we're going to go ahead and skip the set kind of, but I'm going to show you something that you're going to have to do. I'm going to give you a little supplemental assignment so you'll have two different PDFs. So here we go. This is basically going to give you some rules. So the first rule is going to say x to the 1/2 power. Okay, that's going to be the same thing as the square root of x. So here's one rule. And you can call this converting from between fractional exponents and radicals. So back and forth between radicals and fractional exponent. Radicals, anything with like a square root symbol, but it could be a cube root, a fourth root, or whatever. And a fractional exponent just means that you have a fraction as your exponent. Okay. So the reason it's so important is we normally convert because we don't know what the heck a fractional exponent even means. Okay. Normally, if I say x squared, that means x times x, 2 times. Or if I say x to the 3rd, that means x times x times x, 3 times, right? But what does it mean if I say x to the 1/2 power? Multiply x by itself half a time. It's easier to understand the square root of x because the square root of x means what 2 numbers multiply together to give me x. And so that's why sometimes radicals are important. So here's rule number 1, okay? All right, the next rule is going to be, so that one's specifically if you have 1/2 in the exponent. This one's if you have any fraction. Okay, so I'll use n on top and m on the bottom. So for any fraction, it's going to be the root for sure with our big value x in there. Okay, and the m is on the bottom of the fraction. That's your root, and your exponent is the other number. So the way that I like to remind students is this is called the root. Whatever goes there is your root. If it's a 2, it's a square root. If it's a 3, it's a cube root. And if you think about this n over m as a tree, okay, the roots are always on the bottom. So the root of this always goes on the bottom, okay? And the other number goes up top, Okay. So an example of this would be if you threw numbers in there. Actually, I'll just put an example here. Let's say I said the square root, let's say I said convert x to the 2/3 power to a radical. Okay. Well, the first thing we got to do is make a square root symbol and put our base or our big value of x underneath. Okay, my root is 3 because that's on the bottom of the fraction. And then my 2 goes there. And so now I have converted using numbers. Okay, so there's a good example of that. So make sure you have those two rules. You have these two rules in your comp book, and maybe this with this example. Okay. Now, just an example really quick of the 1/2. Okay, x to the 1/2. How does that convert? Well, you put an x there. The 2 is the root, and the 1 goes there. But x to the first power is just x, and the square root is invisible. So these are my two invisibles. Okay, if you don't have any number there, then you know that you have a 2 on your root, and you know that your exponent is 1 where your base is. So just to help out a little bit with that. Now, one more thing I do want to bring up that you can put into your notes is what if it said, like, I don't know, 3x, and we'll say to the 4/5 power. How would we convert that to a radical? So first of all, the entire 3x is being raised to the 4/5 power, so that needs to be here. And you can either put the 3x in parentheses, or you can put it on the outside. So for this one, I'll just put it on the inside. And then your root is 5, and your exponent is 4. Okay? Your root is 5, and your exponent is 4. Or you can write it like this. The 5th root of 3x, and all that could be taken to the 4th power. So both of these are okay, but you have to make sure you have parentheses because that entire 3x is being raised to the 4/5 power. Okay? So now you're going to have some problems like that. That's the one of the worksheets I'm going to give you. All right, this is some other stuff I want you to put in your notes because you should know the rules of exponents. So go ahead and follow along. And I'm going to give you some examples of this as I go. So make sure you put this in your composition book. All right, I'm going to go ahead and make this full screen. That way we can do a better job. All right, the first rule is called, actually I'm not even sure what they're all called, but here we go. Let's just say we did x to the n power times x to the m power. Okay, x to the n times x to the m. All right, this one's actually called the product rule, so I guess I could write that. I should have known what this is called. So this one's called the product rule. So product rule. And the product rule says that you're going to add the exponent. So this turns into x to the n plus m. Notice you have the same base. These only work if you have the same base. So if you're multiplying two things together, then you're just going to basically keep the base and add the exponents. Okay, an example of this. Okay, an example of this would be, let's say 2 to the 3rd power times 2 to the 4th power. And if you add 4 and 3, you get 7. And then you could actually solve this. But this is it simplified. And then if you solved it, you would just go ahead and put your answer there, which for this one happens to be 128. So this is all the rule, but you could just see that I added these two together. All right, there's the product rule. The next one's called the quotient. Okay, quotient means dividing, product means multiplying. So if you're dividing now, let's say you did x to the n divided by x to the m. This is very similar, but instead of adding, you are going to subtract. Okay, here's your example. If I had 2 to the 5th power divided by 2 to the 3rd power, 5 minus 3 is 2. And I'd get 2 to the 2nd power. Recall my base is the same. And so this is basically it simplified down. Okay, so there's the first two rules. All right, make sure you're writing these in your notes. These are very important. These will be on the final. Okay, they will be on the final. This should be review. I think we talked about this in IM1. All right, next rule is called the power rule. This is if you raise a power to a power. You're always going to have parentheses for this one. Okay, so let's say I had x to the n and I raised that to the m power. Everything inside the parentheses is being raised to that power. Okay, and on this one you multiply. This is the same as x to the n m or n times m. Okay, so here's your example. Let's say I said 2 to the third power, all to the fourth power. This turns into 2 to the 3 times 4, which equals 2 to the 12th power. And then you can solve this, which ends up giving you 4,096. So if you did this one, this is it simplified, and then the final answer, if you can give me a final answer. All right, so there's the first three rules. Another rule is called the negative exponent rule. Okay, so make sure you get this one. This is the rule of negative exponents. We never want to leave an exponent negative. Okay, it's always need to be made positive, because what does it mean to say like 2 to the negative third power? You're going to multiply 2 by itself negative 3 times. That makes no sense. So there's two different kind of rules. One of them says, okay, what about x to the negative n? Okay, that's going to turn into 1 over x to the positive n. Okay, just a little tip, there's really a 1 on the bottom of this if I was to make this a fraction. So all we did was flip the fraction and then make the exponent positive. Okay, the other way to do the rule is if you had a 1 over x to the negative n, this would turn into x to the positive n, and then over 1 if you wish. Okay, but this is the rule. An example would be, I'll just do example of both ways. Let's say I had 2 to the negative third power. That's the same thing as 1 over 2 to the third. And 2 to the third equals 8. So 1/8 was your answer there. If I did another one, let's say I had a 1 over 2 to the negative fourth power. That's the same thing as 2 to the positive 4 power, which equals 16. Okay, so there's two examples of that and how that's used. And then last rule that I want to tell you right now, I believe, is the zero. I don't even know what this one's called. Let's see if I can find the name. Oh, okay. There's a zeros rule and the ones rule. So I'll just give them to you. Let me just make sure. Hold on 1 second. All right, so there's the quotient rule, the power rule, the negative exponents rule, and we're going to say the zero rule. Okay, that just says that x to the 0 equals 1. Super simple. Anything to the 0th power equals 1. Example, let's just say 47 to the 0th power equals 1, or negative 8 to the 0th power equals 1. Anything to the 0th power is 1. And the last rule is called the ones rule. And that's just saying anything to the first power equals whatever the base originally was. So for example, if I said 10 to the first power, the answer was 10. If I said negative 3 to the first power, the answer is negative 3. Okay, so here's a couple special rules. The zeros rule and the first rule, and you should have 3, 4, 5, 6 rules in your composition book. Okay. Now, part of the assignment is going to do 15 through 20. So sometimes you have to do multiple rules. And so I'm going to give you an example that looks like the hardest one, maybe one like 19 and one like 20. So let's say we had 3 to the 5th power divided by 3 to the 2nd power. That's multiplied by 3 to the 8th power, all divided by 3 to the 2nd power. Okay, so right off the bat, you can do this whatever order you want, but I see this division happening first. Okay, so this side's going to turn 3 to the 5th divided by 3 squared. You just subtract them, and you get 3 to the 3rd. This multiplication sign drops down. 8 minus 2 is 6. And now we can add them. Okay, so first we did the quotient rule to get this part. And then I did the product rule to get this part. And then you're going to go ahead and give your final answer on that. And so if you put that in your calculator, you get 19,683. And this would be the answer for this one, would be all this, okay? All right, an example of one that would maybe look like number 20. So again, you just do whatever you can first. So the number 20, let's say I had, we'll use a different base. We'll say 2 to the negative 6 power. We'll make it a negative 4 power times 2 to the 5th. We'll make it the 8th power, all divided by 2 to the 12th power. I don't even know how this is going to work out. I'm just making it up as I go. But right off the bat, I notice we have the product rule going on here. Okay, we could do that first if we want. So negative 4 and 8 combined gives us 2 to the 4th power, all that divided by 2 to the 12th power. Then we could just subtract 4 minus 12 equals negative 8. And then we said that we don't want negative exponents, so then we could just make this 1 over 2 to the 8th power, which equals 1 over whatever 2 to the 8th power is, which happens to be 256. So this would be my answer for that one. Another way you can do it is you could have gotten rid of that negative exponent first. So I'm going to go ahead and solve it one more time down here. Okay, so if I had 2 to the negative 4, maybe I want to rewrite this as 2 to the 8th on top. Go ahead and put 2 to the positive 4 on bottom. So we just switch positions and make it positive. And then now we have the problem that looks like this. Okay, so instead of taking care of the negative exponent at the end, we could do it in the beginning. And then you can product rule the bottom. So you have 2 to the 8th. And then on the bottom, you have 2 to the 16th. Okay, and then now whenever you subtract them, you get 2 to the negative 8th, and then you're back at 1 over 2 to the 8th power. So I guess it didn't actually save you any time. That was one step longer, but you can see that it works. So sometimes you have to do multiple rules in the same problem. All right, guys, make sure you do on this worksheet that I'm showing you, you're going to do problems 6 through 10. Then you're going to come down and do problems 15 through 20. And then you're going to do the other worksheet that I create. Have a great day.